Okay, time to figure out how this logic's working. Alright, and another thing I'm going to tell you, that all the different combinations that we seem to have left to do of this scenario here, for example, if you have a 10 minus 16, or here if you have a negative 10 plus 1, or a negative 1 plus 16, where things are crossing 0 and whatever, I'm going to tell you right now, these two methods that we have made are the only methods we're going to need in order to do all of these different combinations of things. So don't concern yourself that we're going to have to make like a few more of these. This is the last one. So let's figure out how the heck this thing is working. Alright, so let's take this step by step, come up with an example of two arrays. And this one was the one that was giving me problems, so I'm going to use this example of 100 and subtracting from 1. Alright, and of course all of the rest of them is initialized to 0. So let's go step by step through how this is working. Again, we have a round integer, or I should say a borrow integer, shouldn't we? So let's see, first thing is we realize it's initialized to 0. Alright, so here we're going to be subtracting this row, because that's the first thing we're doing. So let's see, result round int is initialized to 0. Okay, got that. What's next? We go into our loop and we are accessing index number 79 of here, index number 79 of there. So that's when we're actually doing our arithmetic. Let's see. Yep, that's when we're doing the arithmetic. So when you have 0, we end up with a negative 1 here. Alright. So now we test this. Oh, okay, now I'm starting to understand how exactly this thing's working. So when we see that the result int is less than 0, which is a negative value, we add 10 to it. So negative 1. Oh, and of course we had made the round int 0 for the next round of the loop. But of course this is about to change, because once we realize that the result integer, which is negative 1, is we're going to add 10 basically, and we're going to add 1. We're going to make the round integer negative 1, or the borrow integer. Oh, I just lost everything. Damn it! I hate when that happens. Alright, so let's go back to where we were. Alright. I'm sorry for that, Miss Heap. I blame the Zoomit program. It should ask me if I'm sure I want to exit before. But whatever, I'm okay. So r is equal to 0, we end up subtracting, we get negative 1. So r is set up for 0 for the next round, and here we add 10. Alright, so this ends up giving us 9, and this is the result that we store in the which would be the digit character array. We would store 9. Alright, so next, let's see, of course we changed the round int from 0 to negative 1, so let's get rid of that 0 and change it to negative 1. So we're going to do the arithmetic for this array column here. So this has 0, this has 0, this has 0, this has 0. So 0 minus 0 is 0, plus negative 1 ends up being negative 1. Now if the result, now the round integer of course is always set to 0 here, but if the result integer is recognized, this result integer is recognized to be less than 0, then we add 10. Alright, so this ends up being 9. Alright, and we also have changed this to -1. And now we can store that there. 9. So finally here we have 1 minus 0, which is 1, and 1 plus -1 ends up being 0. Here's our result integer. Now 0, when we go into this test here, is 0 is not less than 0. So this just becomes the answer. And of course, recall the very important thing, that when this result is not negative, this will just stay 0. So we're not adding a -1 as a round integer anymore. So you can grab this and stick it in there as a result, which is 0. And this is the correct answer, 99. So that gives you some insight into how this method is working. So now I bet you're probably asking yourself, okay, we have solved this specific type of scenario when and let me put in a comment here, when I does not cross, when the subtraction does not cross 0. Now here, subtraction does cross 0. Alright, so basically, in order for this to work, what are we going to have to do? So this is a scenario where we have 10 minus 15. So what would I do as an elementary school kid to determine the answer for this? Well, I would actually do 15 minus 10. That's what I would do. And I get a result of 5. And since this is the bigger negative number, I just make the answer -5. So all I'm going to do is I'm going to call this method simply reverse the arrays. Since I know O is bigger than I, I'm going to have so as I say, when given this situation, all I'm doing is I'm switching them around. I'm doing, in reality, 15 minus 10, which we know this method is perfectly capable of handling, and I'm coming out with a result of 5. And all I'm doing is I'm changing that result, the result sign, to -5. That's all we're doing. So you can see it happening, really. Let's see, how can I explain this? I here is 15. I is equal to 15, and O is equal to well, I'm getting confused. Alright. I is equal to 10, O is equal to 15. Alright, so all we're doing them is we're switching them around. We're doing 15 minus 10, as you can see how it's accepting the parameter, and then we're spitting out 5. And now we have to return a signed value. So guess what we're going to simply return? We're just going to return -1. And now this works the other way. So if I, for example, put in something, let's see, -250, it should come out with, let's see, something's not working. We'll solve it in the next video.